Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos. Lesson 5. Periodic classification of elements. At present, 115 elements are known to us. Around the year 1800, only 30 elements were known. All these had seemingly different properties. Scientists gathered more and more information about the properties of these elements. They found it difficult to organize all that was known about the elements. They started looking for some pattern in their properties, on the basis of which they could study such a large number of elements with ease. Early attempts at the classification of elements. The earliest attempt to classify the elements resulted in grouping the then known elements as metals and non-metals. Later further classifications were tried out as our knowledge of elements and their properties increased. Dobereiner's Triads. In the year 1817, Johann Wolfgang Dobereiner, a German chemist, tried to arrange the elements with similar properties into groups. He identified some groups having 3 elements each. So he called these groups triads. Dobereiner showed that when the 3 elements in a triad were written in the order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic masses of the other 2 elements. For example, take the triad consisting of lithium, sodium, and potassium K, with the respective atomic masses 6.9, 23.0 and 39.0. Triads as formed by Dobereiner: first triad, Li, lithium, Na, sodium, K, potassium; second triad, Ca, calcium, Sr, strontium, Ba, barium; third triad, Cl, chlorine, Br, bromine. Iodine. Newlands Law of Octaves. In 1866, John Newlands, an English scientist, arranged the then known elements in the order of increasing atomic masses. He started with the element having the lowest atomic mass, hydrogen, and ended at thorium, which was the 56th element. He found that every 8th element had properties similar to that of the first. He called it the Law of Octaves. It is known as Newlands Law of Octaves. It was found that the law of octaves was applicable only up to calcium, as after calcium every 8th element did not possess properties similar to that of the first. It was assumed by Newlands that only 56 elements existed in nature and no more elements would be discovered in the future. But later on, several new elements were discovered, whose properties did not fit into the law of octaves. In order to fit elements into his table, Newlands adjusted 2 elements in the same slot, but also put some unlike elements under the same note. Cobalt and nickel are in the same slot, and these are placed in the same column as fluorine, chlorine and bromine, which have very different properties than these elements. Iron, which resembles cobalt and nickel in properties, has been placed far away from these elements. Mendeleev's periodic table. The main credit for classifying elements goes to Dmitry Ivanovich Mendeleev, a Russian chemist. He was the most important contributor to the early development of a periodic table of elements wherein the elements were arranged on the basis of their fundamental property, the atomic mass, and also on the similarity of chemical properties. Achievements of Mendeleev's periodic table. Mendeleev had to place an element with a slightly greater atomic mass before an element with a slightly lower atomic mass. The sequence was inverted so that elements with similar properties could be grouped together. For example, cobalt, atomic mass 58.9, appeared before nickel, atomic mass 58.7. Mendeleev left a number of gaps in his table to accommodate the new elements which would be discovered later on. So Mendeleev boldly predicted the existence of some more elements. He even predicted the properties of some of these elements and named them as Eka boron, Eka aluminium and Eka silicon respectively. Later on the elements were discovered. For example, gallium replaced Eka aluminium and it showed properties similar to that of aluminium. He gave the proper position to the noble gases which were discovered later on, without disturbing the existing order of elements. He placed them in a new group. Limitations of Mendeleev's classification. The position of isotopes could not be explained because isotopes have the same chemical properties but different atomic masses. If the elements are arranged according to atomic masses, the isotopes should be placed in different groups of the periodic table. The atomic masses do not increase in a regular manner in going from one element to the next. He could not assign a correct position to hydrogen in his table because hydrogen has some properties similar to alkali metals and some properties similar to halogens. Modern periodic law. This law was proposed by Henry Moseley, a scientist, in 1913. According to this law, properties of elements are the periodic function of their atomic number. It means that the properties of elements depend on their atomic number and the elements are given positions in the periodic table on the basis of their increasing atomic number. As atomic number determines the distribution of electrons in the orbits, and electrons of the outermost orbit determine the properties of an element. Groups and periods. In the modern, long-form periodic table, there are 18 groups, vertical columns, and 7 periods, horizontal lines, in the modern, or long-form periodic table. The number of the period is equal to the number of shells in the atoms of the elements belonging to that period. Trends. In Mendeleevs periodic table, the properties of elements are periodic functions of their atomic mass. It has 8 groups. No place could be assigned to isotopes of an element. There were 3 gaps left by Mendeleev in his periodic table. No fixed position was given to hydrogen in this periodic table. No distinction was made between metals and non-metals. Transition elements are placed together in group 8. Inert gases were not known at the time of Mendeleev. Trends. In modern periodic table. Valency. Elements belonging to the same group have the same number of valence electrons and thus the same valency. Valency in a particular period from left to right first increases as positive valency and then decreases as negative valency. Example, in elements of second period, Li has 1 plus valency, then B2 plus, B3 plus, C4 plus covalency, N3 valency, then O2 and F valency. The atomic size or atomic radius increases as we move down in a group and it decreases as we move from left to right in a period. Atomic size increases down a group due to the increase in the number of shells. Atomic size decreases along a period due to an increase in the nuclear charge which tends to pull the electrons closer to the nucleus and reduces the size of the atom. Metallic and non-metallic properties. In the modern periodic table, metals are on the left side and non-metals on the right side of the table. A zigzag line of metalloids separates metals from non-metals. Metallic characters decrease from left to right in a period and increase while going down in a group. Non-metallic characters increase from left to right in a period due to increase in the electronegativity, and these characters decrease from top to bottom in a group due to the decrease in the electronegativity of atoms while going down in a group.